Hi guys, welcome back. So far we have been using the stocks dataset, which is a file in text format with each record being a line item in the file. In real world, however, the dataset you're going to handle may not be as simple as a line by line text file. One of the popular formats these days is JSON, JavaScript Object Notation. The reason JSON is so popular is because it allows your dataset to be complex and nested, and your dataset can be flexible in terms of structure. So that is why we chose to use JSON format to explain collection data types in Hive. In this lesson, we are going to stream data from Twitter in real time and use the data from Twitter with Hive. Twitter data is rich and dynamic, and it's a perfect source to learn some key concepts related to collection data types in Hive. We have broken this topic into two lessons. In the first lesson, that is this lesson, we will see how to bring data from Twitter. In the second lesson, we will look at the structure of the dataset and do some interesting analysis on Twitter data using Hive. Does that sound like a plan? Okay, let's get started. We are going to write a program to listen for only food-related tweets, and we'll try to find some influential tweeters in that topic using Hive. Why influential tweeters? Because when you're influential, you will tend to have a lot of followers on Twitter, which means people like to hear what you have to say. Also, they will most likely listen and follow what you have to say. Take for example Bobby Flay. He's a celebrity chef and a well-known TV personal in Food Network, and he has about 1.28 million Twitter followers. If he tweets that a restaurant is good, all his followers will most likely generate an interest in that restaurant. Companies are dying to find these influential people in their relevant area so that they can listen to them for feedback, comments, suggestions, and could possibly do targeted marketing and reach their followers of the influential person. Our goal is to identify influential people in Twitter in a specific area. We'll choose food as our area of interest. Now we know what our goal is. We need to get data from Twitter to analyze using Hive. Let's see what do we need in order to stream data programmatically in real time from Twitter. First step, let's see how to get tokens from Twitter's developer site. Twitter has a very good documentation on how to get access tokens here. You can find this link in the lesson notes. Follow the instructions here. It's very simple. You would first create an application by visiting My Application. You can give any name to the application. Then click on Create My Access Token button to create tokens. You will receive Consumer Key, Consumer Secret, Access Token, and Access Token Secret. 4 keys or tokens. Save them in a safe place as you will need to specify the tokens in the program that we are going to write next. Now we have the tokens, let's look at the program. You will need 2 jars from Twitter4j library, Twitter Core and Twitter Stream, which you can download from twitter4j.org. Once you have the jar, add them to the class path. The program takes in 2 parameters, which you have to provide to run the program. The first parameter is the location of the properties file, which has all your tokens and keys. The second parameter is the destination file where the live tweets will be saved. Let's look at the properties file. The first 4 properties list the tokens or keys you downloaded from Twitter. The 5th property in this file will be a list of food-related keywords that we will use for filtering tweets in the Twitter stream. The program itself is very simple. Let's look at the program's constructor first. Here, we will load all the tokens and keywords from the properties file. Then we'll set all the tokens in Configuration Builder and we'll create a Twitter stream using Twitter Stream Factory. Next, let's look at the Status Listener class. This is an important class in the Twitter Stream library. This class has few functions that we can use to dictate what actions we need to perform on specific events. For example, the onStatus method is called automatically when we get a new tweet. Since we want to write the tweet to a file, we will add code to save the tweet to the file in the onStatus method. We don't have to worry about the remaining functions in status listener for our use case, so let's just list them, but we won't define them. Now let's look at the start Twitter function. Add the newly created status listener to the Twitter stream and get all the food related keywords from the properties file. Once you have the keywords, use the filter query to track the keywords. Start the Twitter stream using the filter method along with the query that you just created to track only the keywords we are interested in. We are going to just track food related tweets in our program. So our keywords will have food related words, as you can see right here. So by adding this filter, we will only listen to the tweets that have food related words from our keywords that we supplied, and the rest will be ignored. Finally, we call the start Twitter function from the main method. I'm just running the stream for only 5 minutes and then I stop the Twitter stream using twitterstream.shutdown function. I've already exported this project from my Eclipse into a jar and I have copied the jar into the cluster. Let's now log into the cluster and execute the jar file. The jar is in location hirw workshop hive twitter twitter.jar. As I said, it takes in 2 parameters. The first parameter is the property file and the second parameter is the destination file where the live tweets needs to be stored. Now let's copy this and execute this in our cluster. As you can see, we have started the program. Now the program is downloading all the tweets that has food related keywords. And this program will run for 5 minutes and then it will shut down. While this program is running, let's look at the structure of a tweet. Twitter has an excellent documentation to describe the structure of a tweet right here. The very first thing you will read is, consumer of tweets should tolerate the addition of new fields and variance in ordering of fields with ease. Not all fields appear in all contexts. It's generally safe to consider a null field, empty data set, and the absence of field as the same thing. As the documentation says, the Twitter data is not strictly structured. So Hive is an excellent tool of choice to analyze this data. The actual text of the tweet itself can be found in the property text. Inside the tweet object, you will find the user object, which has a collection of its own properties. It has several useful information that we'll use, like screen name, followers count, location, etc. Followers count inside the user object will let you know how many people are following a particular person who sent out the tweet. More followers means more influential the person is. One more important thing to notice is that the user object is a collection itself, meaning it has several other properties which in turn could be collections. Let's look at an actual tweet itself. You can see the text object that we talked about, which is actually the text from the tweet. Listen to this tweet. I need so much food in my tongue. I don't know where to start. Where I'm going to eat, it's definitely more thought-provocative than accounting. That's a great tweet, right? Now look at this user object, which is quite huge, and also you will see other nested objects inside the user object. Now we need to worry about how to represent the tweets and its related objects in Hive. Let's look at that in the next lesson. Now let's go back and check our program. Our program is now complete. It ran for 5 minutes and it downloaded the tweets that had food-related keywords that we supplied. Now we have to upload this data set into HDFS. So let's summarize what we have learned so far. We now know how to get live tweets from Twitter using a Java program. We also looked at some important properties inside a tweet, which is of JSON format. We now also have the Twitter dataset that we can use to analyze using Hive. In the next lesson, we will look at how we can represent the tweet dataset in Hive, and we'll look into some interesting analysis with the dataset. With that, let's wrap this lesson. See you in the next lesson.